Good afternoon, everyone who have joined us today. Sorry for the delay. I think now we can get started. So, let me just start off with giving a brief intro to Antwork platform. Antwork is an experiential learning platform, and what we are trying to do here is to bring the years of experience from folks like Saurabh here and a lot of other professionals, which they can actually share with the people who want to build career in this any other field. We do provide some of the premium services of personal trainings and boot camps in data engineering, cybersecurity, and other fields. And do check the Antwork platform out. There is a lot of free content is also available from experienced professionals, senior professionals into other domains also that would be able to help you out. So without further ado, I would like to get on with today's session, which is primarily focused on the cloud platform and their use on the data engineering field. So Saurabh, can you please go on to the next slide?
Sure. So yeah, this is about
Yeah.
myself.
So
Okay. Yeah.
I think Saurabh will be able to give his intro in his way like later, but I would just like to introduce him formally. So he's currently working as a data engineer as a brick, and previously he was a technology analyst at Infosys. I think he have like 4+ years experience in this field, and a lot of his work is revolve around analyzing data, building those infrastructure for the data, and using the data-driven decision-making implementation of that into the organization that he is currently associated with. So now I would like to just sort of invite you to stage, and over to you. Please take this forward.
Sure. Thank you, Digvijay. So first of all, very good afternoon, guys. And so enough about my introduction. So yeah, as Digvijay told me, I'm working as a senior data engineer in a company called Quantify, and I've like previously worked in companies like Break and Infosys. I've started my career from Infosys, and since past 5 years, around 5 years, I've been working on these kind of stuff and all. So let me straight away tell you guys like what will be the agenda for this overall session. So I'm going to talk about what is cloud first of all. In a layman terms, I will try to tell you guys how cloud platform works, and in the specific in the data engineering field, what is the role of cloud? How a data engineer or a data scientist maybe can make use of cloud to make the better business decision, right? And obviously, what's the advantage over a typical data schema solution over cloud? And I'm going to talk to you about like which cloud platform are there in the market right now, and uh, what is the difference between that, right? And in the end, like I will tell you guys like a basic uh, end-to-end example where we can use our data engineering solution over cloud, right? Then I will obviously going to have a good Q&A session, and I'm expecting you guys to like ask as many as question you want to ask in terms of anything. Okay, so firstly, let me start telling you guys specifically what is cloud. In layman terms, let me tell you that before jumping directly into the definition of cloud, let me start what is the scenario like 10 to 12 years back when there is the cloud platform is not that as good here in India. So let's say you are having a company, it's like an e-commerce company, let's say, and you have around 1 million customer, which is like hitting in your website or in your online store kind of thing on a daily basis. And so how do you think this company like store their overall data schema, their servers, their applications that they hosted? So initially, what happened that they used to have their own servers where they used to buy infrastructure as a service kind of server, where they used to directly pay for the manual hardware stuff, and they used to hire a lot of network engineer kind of guy and the hardware engineer kind of guy to configure all those things. and then their company is up and running. So what was happening, that as time is passing, like a lot of customer are increasing, a lot of requirements are going in the market, and they eventually have to like increase their business in terms of their infrastructure on a like a quarterly basis. So if they're not going to expand, the business is going to shut down. And it's all about competition here in India, guys. So we need to like scale our infrastructure on a like a daily basis kind of thing, right? So cloud is the same thing, but instead of having our own hardware structure in our room, we are paying some data centers to host our structure, to host everything. Like, so in terms of storage, let's say you have I talked about the e-commerce company. So uh, what do you think, like, what are the different things that e-commerce company handle, like their warehouse data structure, their data schema, every type of data schema they have. They are like dealing with terabytes of data on a daily basis, and or all the uh, images, you can say, all the file system you can remember, they have that, and they have to deal with those on a daily basis, right? So cloud, or any cloud platform, they obviously going to support you the storage of it, their server cost. They have their own dedicated server that you have to like opt it on a like a monthly basis or on a yearly basis. You have to like give them charge on that only rented period only. They also give you the option of your private cloud. So let's say you have your own intra server, intra domain server, where you don't want where you don't want the outside public to hinder on. So they don't also provide that. And they have a lot of optimal database services to provide into. So let's say you have, if you want a SQL data structure or no SQL data structure, anything, they have that service in that platform. You can just opt it for that service, and you can like start doing your uh, business, or making a business decision in a like better and optimal way, right? And the good thing about using the cloud platform is that you can easily use and integrate any application from your system to the cloud, right? So I can like also tell you, like, we generally in India, that what I have like seen, we have divided the cloud in three different arena, right? So we have like software as a service. So software as a service is like, so let's say you have a local directory in your system, and you are storing file over there. Okay, so instead of accessing your local directory, now we are using Google Cloud, sorry, Drive, right? Box.com, Dropbox, Drive. So you don't need to like take care of the files that is in your system only. So if you need that file in your if you're in somewhere, if you're in some place else, then you can easily access those files by just log into your drive.google.com, your mobile phone, and you can access that file, right? So this is something what software as a service is. And then we have something called infrastructure as a service. And infrastructure as a service uh, is type of a cloud platform where a whole infrastructure is going to be available for the end user. So who are the end user? We are the end user. So let's say I want to open my company, and it's like I have to like uh, have a space for, let's say, 100 GB. I want a space for 100 GB. Then I can easily pick up any cloud platform, and accordingly I can like opt those services. Let's say I need some new SQL database. I need the storage of 100 GB per for a particular amount of time, and I can easily opt it. So if my business is going into a boom, let's say, then I realize that, okay, I need some more storage, then I can easily, by one or two click, I can easily opt uh, big data warehouse system or big storage system also. So this is something called IaaS, is infrastructure as a service, which is obviously all the clouds we have, like AWS, GCP, and Azure, right? We have something called platform as a service. Platform as a service is specifically for a software developer, software engineers, or data engineers also. So what is platform as a service? Platform as a service is just a middleware platform that software engineers do. Let's say, for example, Salesforce, right? In Salesforce, we can do any type of data modeling and data optimization thing. And this is only like specific for the modeling techniques, and there are plenty of them. So if you are a network engineer, let's say, and obviously you need to like take care of 100 of routers on a daily basis, and those routers are responsible for like 1 terabyte of logs that is coming into the system. So you can easily log into any load balancer. So load balancer is a thing which divide the load uh, to a different routers if the optimization is not that good. So you can easily optimize, you can easily monitor those load balancers. So this is something, a platform as a service, which is dedicatedly designed for the software engineers, to the network engineers, to the intra company domain system, right? So yeah, so Digvijay, you, is it something that we need to take a poll for, like, or should I continue?
Yeah, so we are launching a poll to just get an idea about like what is the sort of audience that we have.
Yeah. Okay.
Bindu, can you launch the poll?
Guys, there is a poll in your screen. Kindly please. Uh, oh, nice. We have a freshers too in our meeting. Great. Software engineers. Great. Great.
I think we can move ahead.
Okay, great. We have around 30% of software engineers. So I'm thinking that they are like working on a full stack development area, and I will make sure that like what is the role specifically for using the data engineering technologies for software engineers also. And oh yeah, great. We have around 18% of data analysts. Uh, the great thing is that we have 30% of freshers. So obviously this session is going to be very helpful for them and others. Yeah, okay, great. Sure. Let me quickly move ahead to, yeah, okay. So let me talk to you guys about like what is the current industry standard for the companies that are here in India. So this is specifically for India, I think. Just doesn't matter. Okay. So we have seen that if a company is using a cloud platform, if company moved from an on-premise system to a cloud platform, they have a improvement of around 90% they have seen. So it's clearly like self written here. They have around 93% of all the companies saw at least one area of improvement in their ID department since adopting cloud. So just think about in a way that in the old days, like if we are not using cloud platforms, right? So we have our own database engineer, our own system admin, network engineers, uh, some infrastructure management kind of employees we used to have. So let's say let's think about a situation like Flipkart Big Billion Day. Like, let me give you an example, like in a layman terms. So let's say Flipkart said that, okay, on 1st of October, we are going to launch a big billion sale. Okay, so on a usual days, Flipkart has around like 1 million active customers on a daily basis. And obviously on a big billion day, at the start of big billion day, like at the 12 in the morning, if they are still starting, obviously the customer experience or the customer count is going to increase with 5 times to 10 times, right? So if they are not having any cloud platform exposure back then obviously they have to work on their infrastructure prior to the big billion sale. Like, so you have heard of the situation that their site got stuck, site the servers went down due to a lot of traffic. Why is it happening? So it's just because that their infrastructure is not able to like manage the extra customers that they are coming in, right? They have a capacity of 100 GBs only. Their compute power is for 16 GB, let's say. So it's same that if you are running a big graphical game in your 4 GB RAM laptop, your laptop will stuck. So it is same happening over cloud, over the typical infrastructure schema also, on-premise schema also. So why cloud is playing the role in every company and in every sector, that you can like increase your infrastructure, you can increase your compute power, your storage, everything. You can opt any service by 2 or 3 clicks only. Accordingly, you have to pay on a rented basis. So companies are reducing their cost. Around 64% of the companies that said that after adopting cloud, they reduce their waste and lower energy consumption also. So instead of paying a lot of like millions of rupees of bills for their infrastructure, their private infrastructure, they're just paying a minimal amount to the cloud service platform. So you can say like 82% of all the companies saved money on their last cloud adoption project. So guys, be focused on this particular 2 3 slides. So this is the important stuff that I'm going to talk to you about. So just I'm going to tell you that how data engineering process works here. So we have different sectors divided into a data engineering process. So obviously we have cloud here. Top three market pioneer here: AWS, GCP, Azure. And so we have something called data, we have something called languages, platform, and visualization. So let me start with data here. So each company each company is running, and their primary resource is the data, right? You just name any sector, maybe it's a healthcare, it's a e-commerce, or any kind of sector. Data is the important stuff that they need to work on to make their financial decision, to make their billings go up, and any kind of business thing that they are need to do. The primary resource is going to be a data, right? So obviously data is of any type, like it's structured, semi-structured, unstructured. So structured data is like it has a proper normalization format is there. So you so engineering guys, you can sorry, the fresher guys, you already have like learned about normalization in your database concept, like 1NF, 2NF, 3NF, BCNF, and else. So if your data database schema is properly normalized, that is a perfect structured data that we have. But this is not a story here. Like less than 1% of data that we used to deal with, or you guys going to be deal with in future, will be unstructured. You are not going to be dealing with the structured data. It's your job to make the unstructured data to a structured data, right? So we have any type of data that we are going to have in our system. We need to process those in that data engineering. So I'm talking about all of these by keeping in mind that I'm a data engineer, and what all sort of things that I'm going to be needed in my future to become a good data engineer in any good company, right? So I need to take care of all the unstructured data. I need to know like how unstructured data uh, how structured data works. All the data modeling, data pre-processing techniques I should know to make my data clean, and which is like very useful for the future team. Okay. And I should know at least one language. So Python is the like most like famous language that we use in data engineering. So you can like go with Java also, R, Scala. So every thing works, but yeah, Python you should know. So after that, there is something called platforms. So this is all open source platforms: Spark, Hadoop, Apache Airflow, Hive, Kafka. So obviously Hadoop is for dealing with big data schemas, and Spark, Airflow is an orchestration database document tool where we use in every cloud platform. And we have something called visualization techniques. So this is the important stuff here that any business person will be looking forward to get from a data engineer or data analyst, right? So let's say I talked about big billion sale, right? So let's say I am a data engineer working for Flipkart, let's say, and uh, after a big billion day, that after the sale ended, my my tech lead asked me, my lead or my manager asked me that, okay, Saurabh, give me the data of all the persons who have bought one plus five, okay, one plus 10, let's say. So and give me in a picturized way, like give me in a charted way. And I need a person, I need all the person whose age is greater than 18 years of old and less than 30 years of old. Okay, so what I have to do, I have to like filter out all the customers who have bought one plus 10 from my platform in a big billion sale, whose age is between 18 years to 30 years, right? So obviously I will be needing query language. You can use no, if you are if I'm using a NoSQL language, then I can use MongoDB to query those data, or a SQL if I'm using a SQL platform. And then what I will do for that data, okay, I have a table of like uh, 10,000 people who have bought that phone. So I'm not going to like give that raw data in Excel form to my manager, right? I need to present that data in a visualized, picturized way, in a proper manner. Then my manager or my lead will be able to understand that. Okay, so for that I have a lot of BI tools, which is Power BI, Kibana, uh, quick shift. So Power BI is like pioneer in the market right now. So a lot of people, a lot of the engineers use Power BI for that. You can easily make a dashboard out of it, and visualize anything, like any data. You just need to query that data, and you just need to uh, configure your connectors with Power BI or any Kibana, and you can use. And yeah, so each and every step, the main good, the sweet process of all doing all these things is that every process is available in this cloud platform. So you don't need to configure things manually. So if you need a messaging service, let's say, so what I mean by messaging service is something like, if let's say Flipkart, okay, so you have purchased your phone, your payment is completed, so you got a notification in your system, in your phone, in your notification section, hi, your order is being confirmed, right? Hi, your order is being shipped. So how do you think it's happening? It's not manually, for sure. There is something, messaging system, messaging service is running behind the platform, right? So manually you can configure Kafka according to that, but the optimal way of using that is to like use any orchestration, or sorry, any messaging service tool, right? You can orchestrate those in your system, in your pipeline, data pipeline, and you can use it easily. So in Google Cloud, we have something called Cloud PubSub. You just have to create some topics and subscriber, and according to the callback function that we are going to give, your notification will come. If a callback functions trigger that, okay, your payment is completed from the payment gateway, then automatically the message get triggered in your account that, okay, hi, your payment is completed. If your payment got failed from the payment gateway, if you didn't get a 200 response from a payment gateway, then messaging service get trigger, and it will tell you guys that, okay, there is something wrong in your payment, so you need to repayment your thing again, right? So this is how optimally things work. So obviously a data engineer is not going to manually check tens of millions of customer on a daily basis. So that's the reason we need that these services in an optimal way, and a single guy can manage everything if he wanted to, right? So this is a typical data engineering process in the market right now. So what if you are going to be a data engineer, if freshers are listening to me, if you guys are going to be a data engineer, then what are the n number of things that you need to prepare for, right? So this is again an important slide, guys. So just be focused on that, and just uh, if you have any questions, just please keep it in your mind, or write in your any notepad or something, and in the QA session, please ask as many as question you want. So let me start by giving you an insight about like uh, what is this, like what is software engineering, what is database engineering here in the middleware, and in the end layer, what is software engineering for the all the APIs and API request. Okay, so so the blue pipe that you are seeing here in the first column, it's a pipeline. data pipeline. So this is the important step for you guys. Like you have to like create a data pipeline which can deal with terabytes or petabytes of data, of a streaming data or a batch data on a, like a daily basis or on a eventually basis, right? If your pipeline got breakout in the middle, obviously you are going to lose your data, right? So this is data, you are getting your data from an on-premise system or from a customer end. So talking about the layman terms, let's say on a daily basis, let's say 1 million new users joined Flipkart. They have logged in to their, they have created their new account in Flipkart, and they have entered all their information, their address detail, their card payments detail, and everything. Like so, the data came in, or and apart from customer, we have, so let's say around 10 million new products got listed in Flipkart, right? So this will be around, you can say 1 terabyte of data, easily in an easy catch. 1 terabyte of data is coming in Flipkart on a daily basis. I'm telling you in a minimum way. So what 1 terabyte of data looks like, so what's the story, what's the overall journey of that data will going to be in that Flipkart data pipeline system. So the first green card you can see here, it's a transformation, right? So what I mean by transformation, that Flipkart has some their own set of rules that they perform, that they use their own nomenclature, you can say. So let's say your address detail. So I have write my any like whole address, like 123A XYZ building, Mumbai, pin code something something, right? So there must be some you can say a service running here in the middle, which is able to extract only pin code, which is able to extract only the building name, which is able to extract only the city. Okay, and according to that, uh, that particular information is going to be dumped in their respective database schema. So they must have something related to their pin code schema, pin code database schema, where all the pin code is getting mapped to their respective customer IDs. So my customer IDs, let's say 100, my pin code is 462038, let's say. So obviously this middle system is extracted that information and mapped my customer ID to my pin code system or my complex or my city. Anything can happen. The second layer might be a data cleaning part. So let's say I didn't wrote my pin code, and it was not required in the time of filling my form also. So these processes will take care of those things also. If my pin code is null, let's say, so according to that, they must have some transformation also. In the third system also, there must be some process going on. So this is a series of n cardboards. So when the data comes here at the end of the first column, the data should be very precise, very clean, and it can be easily able to like use for any business insight, right? So in the second column, database engineering came. So as a data engineer, you must have to be frequent in any query language. For a SQL or for a NoSQL, for a NoSQL, you must know how MongoDB works, how to query a petabyte of data using a MongoDB, right? How to query terabytes of data in any cloud platform or any SQL engine by using SQL, standard query language. So we have data lakes, data warehouse, sandboxes, etc. So data comes in. So let's say if NoSQL data is there, it has a different instance in the cloud. If the data is of JSON, XML, CSV format only, and there is no querying getting implemented on those data, then it will come here. So it's totally depend on the type of the firm, type of the company requirement, that on the basis of which they are like dividing their data, and which database schema and how their database schema is going to work is totally depend on the company. But typically it looks like that each company has their own data warehouse system. So let's say if Flipkart is using GCP, Google Cloud Platform, all their database schema, their data warehouse is going to work in BigQuery. So BigQuery is nothing, it's not like a new thing in the market. It's the same thing, like how SQL works. In the left hand side you can see all your database schema, or all your relationship between the tables, and in the right side you just need to write a SQL query to fetch the data, right? And uh, same as data. So data lake is just you can, in data lakes you can like store your structured, non-structured, any kind of data, right? So each cloud platform has their own data lakes services available. You just need to like use any of them. If you are working in a AWS, let's say, so you need to use that accordingly. If you're working on GCP, you need to use GCP services accordingly. Many companies use hybrid cloud also. By hybrid cloud, that some of their services are in GCP, some of them are in Azure, some of them are in uh, AWS. So it's totally depend on the company requirement, first of all. Then after that, uh, you can see in the third column, all the APIs, SOAP, REST, virtualization is there. So what do you mean by virtualization? Let me tell you. So you can like virtualize your whole infrastructure in a single, let's say, cube. And that cube, you can like, if any changes you have done in future, that cube will going to responsible for that, for that change in the future transformation. So you can easily virtualize anything using Kubernetes. So this is like a different concept. I'm not going to like jump into that, but you can also get those services in any cloud platform. So uh, who are the guys who are going to work in these things? So some applications are there, okay, some data analyst got is there. So data analyst is not going to check these things, right? Like how the data pipeline is working, how the transformation is working, how the orchestration is working. The job of data analyst is to just need with the, or just to analyze the data, right? And do all sort of modifications, all sort of visualization. So let's say I'm working as a data analyst, let's say, and I have an endpoint of I have an endpoint available, which I'm going to hit using any endpoint API service. Let's say from Postman, I'm hitting that endpoint, and I'm getting the that required data, and that data I'm going to use in my data visualization step, right? So same goes to data scientist. So data scientists use that cleaned model, clean data, to building their machine learning model, let's say, and any sort of thing. So all the terms that I have talked to you about like in past 5 minutes, each and everything is available in cloud as a service, as an infrastructure, as a service, that I've like told you guys in a very first step, right? So let's say you are if a data scientist is there in your team, then he or she can build a machine learning model easily using any cloud platform services. In GCP we have something called AutoML. So by AutoML you can easily train your data and easily create any machine learning model according to that. You can use if you want to like remove the outliers, if you want to like tune your parameters, so you can easily do it using hyperparameter techniques. You don't need to write a manual piece of code onto that. So this is the main biggest advantage of using cloud platform that companies getting. Company don't have to pay 50 engineers or 40 engineers to do that simple work. Instead of that, they can hire 5 data scientists, 5 data engineers, and they can like manage their whole company in a single platform, right? So yeah, that's important, right? Okay, so all the things that I've told you in this particular example, this is a simplified version of that. So you have a structured data here, unstructured data, obviously, and you have something called data source. From data source, all the data is coming, and uh, data source is something like Oracle, SFDC, or your any private on-premise tool that is present only in your local system. Okay, so this is, I'm telling you, the process of migrating your on-premise system to cloud, right? So let's say uh, flipkart dot forget about flipkart.com. Let's say there is a rice mill. Okay, so rice mill is running in a simple software that they are able to make in a like a simplified way, and those are only those guys are able to like use that software, right? And there is no connection uh, in the overseas format. So let's say they told us that, okay, our data is getting like increasing day by day, and my software, my local software can't able to handle those data now on a daily basis. So we need to move to cloud. So what services cloud platform is going to provide to move that data in a seamless manner and to reduce their cost, right? So this is the data source is their software that they are using, let's say Oracle DB2, let's say. And there is something called data extraction. So there's in data extraction, what I meant is that there is a data integration layer from cloud to their on-premise system. You need to create a data integration layer between them to extract data on a timely basis, on a streaming data kind of thing. So let's say I am a Google Cloud, let's say, and I need like data on a hourly basis or on a weekly basis, let's say. So I need to create that data integration. Data integration is kind of a bridge between cloud platform and an on-premise system. So I have to create a data integration between those two. The things involved in the data integration is the authentication, encryption, decryption. So they must have some encryption, decryption, or some authentication password running in their data source. So that I have to like ask with those guys, and accordingly I have to create that integration, the pipeline between those. So this is only one of the 10 part of the data pipeline, right? When the data integration is completed and the data is coming on a daily basis, let's say, so after 24 hours new data will come in the data source, and automatically that data integration pipeline got triggered, and according to that my data extraction process will get triggered, and according to that it will come inside my cloud. So if the data is coming inside my cloud, I can do anything out of it, right? So if the customer wants some visualization, some information out of terabyte of data, um, if the customer wants to train some model to do some machine learning prediction, or anything, the cloud platform is there, all the services is there. So data processing will happen. So between data extraction and data processing, data will get processed in their database schema. So you can say data lake, it will get stored in that particular schema after doing data processing and data storage. So before jumping data into the data storage, we need something like this. So batch processing, real-time processing, you need to clean data. So if the messy data or like uh, messed up data is coming, you need to take care of those data. So you can clean the data, you can validate those data. What I mean by validate, so the validation is, so if there is like 50,000 rows in a column there in an on-premise local system, so that 50,000 rows should be there in our system also. If you received 49,000 rows, so that 1,000 rows got missed in the middle system, right? You can't do this is like a bad practice. We just lost 1,000 rows of data, right? So customer will be very pissed if like I'm using a cloud platform, and I'm seeing that my raw data is not similar and is not accurate similar to what cloud platform has, then I'm already going to like give a negative review. Okay, so data validation is an important step here. So we need all the data from here. If the data is missing, then there is something with our data integration going on that is not dealing with those 1,000 rows of data. Okay, so data aggregation, like aggregation, like some median average. So what is the average amount of sale happened in a month? What is the total annual growth company had? So this we can like do from this thing. Job scheduling, so job scheduling is like a vast process. So let me give you some examples. So you can like schedule jobs. What is meant by job is just a process of doing anything, like in terms of data engineering, a process of doing moving data from one point to another. It's a job, right? So you can schedule that job, that you can tell the system that, okay, after 24 hours, uh, 50,000 rows from the Oracle DB2, which is a local system, will be transferred to my data storage here. Storage is just your local hard disk kind of thing, but in cloud platform, you have your own storage. So you can schedule that job, right? So the data came into data storage, and if the data is coming into data storage, you can do n number of things. So here I only have like data visualization here, but you can do anything. Like you can build your model, you can store your data with schema, you can filter or process any data from your data warehouse system. Okay, so in a data visualization you can like do data analytics. You can use that data in any power, in any visualization tool you have. So Google has something, their own kind of service to visualize those data. Amazon has its own, Azure, Microsoft has its own, right? It's the same thing, guys. Like it's not a difference. Like there is no difference between GCP, AWS, and Azure. Is the same thing. Everyone is doing the same job, but with their own nomenclature, with their own services. Okay, so I'm moving ahead with the next slide. So if you guys have any question in these two slides, please note it down, and I will make sure to answer everything in QA session, right? Okay, so first of all, this is, I think I'm already covered those things, but let me like give you some more example, like how, what is the role of cloud in data engineering, like uh, how cloud can optimize the whole data engineering uh, environment or whole data engineering ecosystem, right? So obviously there is like 100 things that we can like use, but here I only mentioned four, which is like the topmost thing that I feel that okay, this is something very good happening here in the market. So some first is cloud storage. So if you are using an on-premise system, if you are using like a local system that doesn't have an internet access, so for that you need to like create a manual backup, right? In every 2 days or every week or every a single day you need to back up those data. And where you guys are going to put that backup? You need storage for that, right? So after 5 years, let's say, your backup is of 10 terabytes. Where you guys like think that you are going to put that backup? So, and let's say some malware attack came, some ransomware attack came, right? Any time of hack, someone hacked your like local system and your data got lost, and you have found that okay, your database engineer or your DBA is on leave for a week, so he didn't able to back those data in the past last week. So you're not going to do anything. Your data is lost, your business is lost, like everything is lost. You can't like restore that data because there is no service of restoration in your local system, right? So this is where cloud storage work. So you can easily back up your files, you can schedule your backups at any time, and out of it, it is completely encrypted. There is no chance of any security malpractices that happened. If there is something happening and system triggers that, it would automatically shut down your system and back up everything. In the end, you are not going to lose any data. So which is what cloud storage and cloud backup is, right? So obviously every cloud service is going to provide all the software, which is a software as a service, right? So let's say Office 365. So if you go to Office 365 or Google Apps homepage, you can check, you can see anything: slides, docs, PowerPoint, sheets, anything, Gmail, meeting, anything you can see in a single homepage. It's a software as a service, which is only for doing a set of things. Like you can easily do it in a single platform, right? You can easily host cloud in a like use any cloud hosting, you can say. So you can use email services, application hosting, web-based phone system, and data. These all services cloud is going to provide. So this is the main difference between using a typical data solution system and a cloud system. In data solution system, I've told you everything is manual, everything is in a local state, local ride, and here everything is like in a cloud platform in a public way, right? So you can see like out of 100% of companies that are using cloud, so 21% of the companies are like using the cloud platform, public cloud platform, like public cloud platform, which is AWS, GCP, Azure, anything, right? only 4% are using private. So what is private cloud platform? Private cloud platform is the same as a cloud platform, but they are private. Like so let's say I have a R&D company, I have a research oriented company, and I don't want my research to publicly I don't want my research to be like seen by public, right? So I will not use GCP or AWS or Azure, though it's completely safe, but I will use, for the safety precautions, I will use some private cloud, which is IBM cloud. IBM and number of companies are providing their own private cloud system, right? So, and 71% are using like the combination of both, which is a hybrid. So you can like, you can see that let's say Quora.com, everyone like heard like read Quora on a daily basis, right? So you can search about Quora, like they have like 2013 or 12 they have moved to cloud. Previously they have their own private uh, infrastructure. So like almost 70% of the services that they have, the 70% of the microservices that they have is running in a public platform, and the 30% are in the private cloud. So private cloud and public cloud, you can easily interconnect with each other. And yeah, so I can also give you one more example for private cloud, that let's say if you go to any company, right, in each company they have their own system which is only dedicated to their employees. Someone from outside can't enter to that system. It's an internet intranet system, the intra server, right? So to access that system from outside, you need to use a VPN, let's say, right? So if you guys are working from a home or freshers, you need to use VPN to connect to a company network. This is the main thing here. Like you can't just log into your company services, inside services from your internet system. You need to firstly connect to the VPN. The VPN will move your IP address to the company intra IP address. Then you can access your system inside system, right? So yeah. So this is I think like I've already like told you guys that what is the advantage of cloud system here. So we have a high speed quick deployment. So let's say in your team some data engineers are there, some data scientists are there. So let's say I'm a data engineer and I found that okay, that data integration got failed. I was missing with 1000 rows. 50,000 rows should come, but only 49,000 rows is coming on a daily basis. So where is that 1000 rows is going? I don't know. So I've checked my data integration code, which I wrote with Python to extract that data from Oracle DB2, and I found some anomalies, right? Some errors. Okay, then I've like fix that code, and I have to deploy that code in the main production server, right? So usually what happened in a cloud typical system, that I have to uh, manually go to my VPN hosting, update my code, and then do n number of things. But here you can easily deploy anything. Like easily you can take the image of one, you can easily like a Docker image. So I'm not going to go to that. So you can easily uh, take an image of one snapshot, and you can easily deploy your code in anywhere. I'm not talking about the code only. It's for anything, any services, whether it's a machine learning model you are trained, or any services that you are using at that moment of time. Okay. So let's say you are working on uh, let's say Python. Okay, you're working on Python 3.6, and all your services are using Python 3.6, and let's say Python 3.7 came, and some services are like needing Python 3.7. So you don't need to update manually all those services that we used to do it in our local system. We need to upgrade our Python environment, our Python interpreter, and all the services that is getting linked to Python, right? You can easily update any service or any software automatically, and it will like save a lot of cost in that. You can easily integrate a lot of services, right? So let's say Skype or Teams, you can say Teams is like a messaging platform that we use in every company right now. So you can easily integrate Teams API to a cloud. So let's say some server went down. Okay, you have like 10 servers and one server went down, and you need an alert. that okay, and you are a database engineer or data engineer, obviously, and you need that okay, if some things got broke, I should have a message coming into my teams that okay, automatic message that hi, this particular server, the IP address of that server is broke. So this integration can only possible in cloud only. There is a Teams API available in the market. You can easily integrate inside that cloud in a single click, right? So this is like a best thing. Efficiency and cost reduction. Obviously, you don't need to pay your like like data center bills, your electricity bills, your staff that is going to maintain those. Data security, obviously, they have like a like best data security solutions available in the cloud service. Like everything is secured. You can implement your own security services also. Unlimited storage capacity. There is no limitation in the storage. According to your, if the business is growing, you can easily opt the storage accordingly. And the competitive edge, this is the most important thing. So I am running Flipkart, my computer is running Amazon, and my another computers are running are in the e-commerce uh, business, right? So if I'm using just a typical local system, obviously my website will be slow, my customer base will be like reduced, and they will go to amazon.com, because amazon.in is using cloud. It's very fast. Everything is like in terms of their shopping experience is great. They just press click, the payment got deducted. They just press place your order, or your order is placed, they just got a notification. But in my local system, everything is slow. So that's a competitive edge. Lot of company, you can google about it. I can also give you some examples, but I think we are running out of time here. I can give you that who didn't move to cloud, and like their business went away, they just bankrupt. Okay. So yeah, that's the main important thing coming to the edge here. uh, in not in India, in the world, we have like three pioneers that I'm going to talk to you about, which is AWS, GCP, and Amazon, and Microsoft Azure. Okay. So a lot of clouds are also there, like Alibaba cloud is there, which we don't use here. So how to choose, like if you are a newbie here, so how to choose which cloud platform you are going to move into? So I honestly, what I would say, just go with anyone. Like any, all the cloud platforms are doing the same stuff, but their name nomenclature is different. Like, right? So in GCP, they have for storage, they have GCP buckets. In Amazon, in AWS, they have for storage, they have S3, right? S3 bucket. So the nomenclature is different, but they are doing the same job. So you do, it's clearly I've mentioned that only the race is between these three guys: AWS, Microsoft Azure, GCP. uh, IBM, Oracle have their own cloud services platform, that but they are basically for public cloud platform, for sorry, for private cloud platform. Okay. So each of three cloud platforms are unique in their own way, and they have plenty of options to select on the basis of the requirement. If you are a startup, let's say, and you need only 10 GB of compute power on a monthly on a yearly basis, then you can go with AWS. If you are a vast organization, you can go with GCP, and it's totally depend on on your requirement, right? So everything is same. So if you are a GCP engineer, let's say, if you are working on GCP for past 3 years, you know 8 to 10 services of GCP, you can easily work on AWS, you can easily work on Azure. Uh, there's like no question about that. You just need to know about the services, what it does. But the main thing is, know the fundamentals here, the fundamental of data engineering, how the data pipeline works, how you are going to create a data pipeline from end to end, where seamless data transfer happen, right? So how it all works, like how cloud platform works like internally. So obviously, I took example of Google Cloud Platform here. So we have two things here. I've divided this thing into two things, which is a front end and the second is back end. So front end is for us. for data engineers, that we can access all the services from the front end, from the computer console, and we can do anything. Like the backend is for the software engineers who are responsible for designing that cloud, which is like a which is a data center. Your data is saved in a data center, that for sure. So how that data center is going to work, this includes that computer servers, storage system, all the programs, and everything that is responsible for keep that data center up and running 24/7 into 365. Okay, so in GCP we have a compute engine. If you are a data engineer, you can like go to compute. I'm not going to dig down inside that, but you can go to compute, you can configure your app engine, you can configure, you can buy your compute engine, like which how much computing power you need for running your company. For storage in data in GCP, you have cloud storage, cloud data store, cloud SQL. According to your data, according to your schema, everything you can use that service for. And all the things that you are going to pick, it is like it is getting articulated in the same way in your backend, in your data center. You can do your big data analytics using BigQuery or any big data tool you can use, and all the services, the cloud endpoints. So if you are like working on a hybrid cloud, let's say you have your own on-premise system also, and on any, and also some any public platform also, you can connect your uh, private network to your public endpoints, right? So that you can also do it easily. So yeah, I think Digvijay, you can continue.
Right.
Yeah, sure.
So
Thanks.
yeah, thanks a lot, Saurabh, for this all session. I hope like people are finding it valuable. I just wanted to introduce, inform people about a program in data engineering that we have launched the second cohort recently. So if you can go to the next slide, I would just like to give a
Yeah.
few pointers. So we'll drop a link in the chat where for people to actually go through the on the website. But on a hindsight, it's a 16-week live boot camp from Antwerp, and here what we are trying to do is we are providing an hands-on experience onto all the technologies in data engineering. Someone who wants to transition their career from their current role, or somebody who wants to get started into this field, this is a really good opportunity. You will get to interact with 9 to 10 mentors who are like senior data engineers, and will be taking up different modules here. On top of it, what we will be also providing you with real world solutions and projects on our platform. And of course, it comes with a 100% placement assistance from our side. So if anybody is interested to know a little bit more about the offering, they can check out the website. Link is there in the chat box. Somebody will from our team will be able to contact you. In the next slide, we also have a sort of path that one can that we typically are following in this current bootcamp, from a little bit of Python to SQL and databases. We teach to sort of build that fundamental for anyone. Then moving forward to Azure cloud platform for the data lake and data warehouse solutions over there. And also, as well as we also covered Hive and HBase and all these things over the big data and Hadoop platform, as well as like all the aspect of data governance management, real-time streaming, and airflow, and everything is something that we cover. This is a sort of 360 coverage in terms of topic that one need to kickstart their career is being provided here. So yeah, anyone, I think that's it from my side. If somebody have some questions to Saurabh or over the topics that we have discussed in the class, please feel free to unmute yourself and ask. Or if you're comfortable, you can also put it in chat.
Guys, any question, like if you didn't understand like anything, like you can ask in a chat or in a like unmute yourself and ask. Like I will try my best to answer it.
Yeah, Saurabh, we have one question here from Sunil. Uh, at each stage in this diagram, data can be consumed and referred to for visualization, analysis, API conjunctions, etc.
Uh, I didn't get the question. Can you please read it further? From whom is that question? Like
Sunil Agarwal.
Sunil, is it possible to like unmute and like ask? Like it will be very very good.
Yeah, hi Saurabh.
Yeah, hi Sunil. Yeah.
So you had that diagram where you are showing all the stages, data source, data
Mm-hmm.
processing,
Mm-hmm.
then the storage, right, and then the APIs comes into picture, all those things. So I want to know, is it like, is it possible that at each stage, each of these stages, and especially when you're using on cloud,
Mm-hmm.
you can see this data, you can consume this data for whatever purpose.
Consume that data like on what basis? Like as a customer or what?
Not as a end customer, like the product team, the data engineering team.
Okay. Yeah.
Can you open the diagram? I
Okay.
think
Wait.
it's
Wait.
the yeah.
This guy.
No,
This one.
the yes, this one or the next one. I think both are similar.
Okay.
Yes,
Yes.
this one.
Yeah.
Yeah. So here you have four, 5 blocks, right? So each
Mm-hmm.
stage, I consider, I'm calling all these blocks as stages.
Okay.
So at each stage, you can basically get the output of the data and just consume it for
Mm-hmm.
whatever purpose, right? That is possible,
Mm-hmm.
correct?
Yeah. 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 Yeah.
Okay, okay.
So it's totally about your business decision. So let's say you have cleaned your data. So let's say your data pipeline come here. Your data extraction, data processing is done. So the data is came here, let's say in this particular moment of time. And so this will go to these set of steps: data cleaning, data validation, processing, scheduling, and all. So if then it will come to data storage. So all the like messed up thing got removed from this particular thing, and then it will came to data storage. So all the data analysts, business analysts, or data engineers, even data scientists can easily consume that clean data in their system to make their business decisions, right? Data scientists can use that data to build a machine learning model, predict something, and provide that same prediction to the business. Data engineer can check that data, can like validate whether that data is good or not in this particular stage, and like this he or she can improve the data pipeline. Data analyst can detect some data anomalies, that okay, after cleaning and after validation also some data is missing, some data uh, is like messed up. So that guy can report this thing to data engineering team or anyone. So in the end, the job is to consume like the unstructured, keep unstructured is to power unstructured data, that we tell you like in a that way also, and make the data pipeline seamless for end-to-end ETL workflow. We are not going to like every small chunk of data is required for us, like to make the decision, financial decision, like in an optimal way, in a quick way.
Okay, yeah, that answers my question. Thank you.
Sure, guys. Anyone else?
Excuse me, sir.
Yeah, hello.
Hello. This is Radhika. I'm a fresher, I can say, as in data analyst. So I'm
Okay.
learning AWS. I'm not quite known about it. So I just want to know that previously you say that all the process we can do it. So मुझे ये पता करना है कि ये सारी चीजें हम मतलब क्लाउड में कर सकते हैं कि आफ्टर मतलब जो आपने बोला कि जब आपने एग्जांपल दिया था फ्लिपकार्ट वाला, तो उसमें जब एपीआई हिट होता है तब पूरा डेटा एक्सट्रैक्ट होता है अपने पास, देन हम उस डेटा को लेकर वी कैन डू द प्रोसेस व्हाट वी वांट टू डू इट, राइट, लाइक डेटा मॉडलिंग और डेटा विजुअलाइजेशन. सो दिस whole processes comes into the AWS or what? I mean, like, मुझे थोड़ा सा
Exactly.
डिफरेंस
Yeah.
समझ नहीं आ रहा.
So what I meant by hitting that API, let's say Flipkart is a completely offline store, which don't have any public software kind of thing, and they have realized that okay, they have to transfer their data to the public platform, to a public cloud, right? So my job as a data engineer, so you can see this diagram, right? So let's say this small chunk here, this is Flipkart. Okay.
Yeah.
So and everything from here is the cloud, everything from here. So my job is to create a data pipeline. First step is to make a data integration between these two guys, this block, big block, and this a small local block. So as soon as I get all the data from the local system to my cloud platform machine, I can use anything. So to straight away answer your question, you can use these things, you can use everything in your AWS. You said you were learning AWS, it's good. So you can use any of those. You just name the service, AWS will have it, or any cloud platform, Azure or GCP will have it.
Okay, thank you, sir.
Yeah.
Sorry, one last question. This diagram, right? So this will be considered as PaaS, right?
Consider as, sorry?
PaaS, platform as a service, correct?
I would say it's like a mix of platform as a service also, and infrastructure as a service also, I can say, because data visualization is a platform as a service. So let's say you have visualization tools like Power BI, Tableau, Kibana, like from Elastic. So that is PaaS, like platform as a service. Data storage, let's say, data storage is like a hardware storage devices like running in the data centers in a like a stack of routers and switches. They are running in an actual data center. So this is an infrastructure as a service, IaaS, you can say.
If my data storage is SQL, in that case, it is not IaaS, right?
Yeah, as I said, it's totally depend on the company requirement. Like some of them use that, some of them don't use it. It's totally depend on the type of data or type of domain that you are working on.
Okay.
Guys, ask as many questions you want.
Yeah, hi, Saurabh.
Yeah, hi.
So I want to ask that how can we handle the unstructured data here?
Okay, so it's a very great question. So unstructured data, let's say you received 1 terabyte of data, and you don't know the relationship between any kind of data schema, right? So you, first of all, you need to start with n number of processes. Firstly, you need to clean that data by naming, by what is meant by cleaning that data. So let's say there is a column name product ID. Okay, so product ID is a unique key, is a primary key for a product, right? So no two products have the same product ID in a e-commerce. I'm talking about Flipkart here, same example I'm talking about. So you received 1 million rows of data, and you checked that the primary column product ID, so 10% of that column is like null. There is no product ID. Okay, so this is a huge bad this is a bad thing. Like, you can't use that data to any of your services in visualization, in building machine learning model. So you need to take care of those things. You need to impute something, or you need to drop those rows. Maybe you need to take the decision wisely. Then you need to validate. Validation is the last step, and then you need to like create a high level like a workflow of all the databases. So let's say you have decided like the consumer data will go to the consumer database, the product data will go to the product database. You will define the relationship between that. Okay, this product ID will come, the the product ID 100 is mobile phone, right? And the category ID 155 is electronics department. So the 155 is a parent relation with the 100. So you need to define those relationship. So in the end you are structuring that data, right? You are like adding the meaning to that data, that okay, what is that data? If I write select if I queried that product ID 100 data, it will come as a mobile phone. Then I can see each and every bit of history just by checking the relationship between that. So which is what relationship diagram is all about. If you like learn in your engineering in the DBMS part, if you guys are from engineering background, from CSI and IT, then relationship diagram is all about this only. So you need to add some meaning, add some value to that data. Okay, so then in the end you need to validate those data, whether the validation is correct or not. Then this is like like there is n number of process to structure those data. I just told you the top 3 or 4 ways to do it, like we used to do as a data engineer on a daily basis.
Thank you so much. That answers my question. And one more question about the data modeling. I want to know about the data modeling. Like I'm not aware about it. I just got to know that there are 2 ways: star schema and snowflake schema. So if you can
Okay.
put some
Yeah.
light on
So
it.
there I would say there are n number of ways to do data modeling. Like star schema and snowflake schema is it's just like a standard that IEEE or maybe some organization created, right? But in the real time, here we are talking about like a real time data engineer solutions, like in that definition. Then we need to like model our data. So first of all, what is data modeling, right? It's the same thing that I've told you, to add a value to that unstructured data, to define a relationship between the document and their parent document, right? So for that, let's say, if you guys heard of a Firebase. So Firebase is something, a document child relationship schema, where we each document has its own child. Each uh, electronics ID, each electronic category has its own set of electronics item, right? So this is totally depend on the type of the company or type of the domain that you are working on. Healthcare has their own data modeling system, uh, e-commerce has its own, and everything like so in the end, if you are a data modeler, there is a specific position for data modelers also in the market. You just need to model those, you just need to take care of the unstructured data in a vast domain, and you just need to design the relationship between those two, between anyone, not those two. You need to just define the relationship between the data. So this is what data modeling in a layman terms is all about. And talking about the types, snowflake and also, this is a company standard, like but company don't use it, obviously. Like they have their own set of techniques that they use, and accordingly you need to work on that.
Thank you so much.
So just to add some things, guys. So like what when I was started to this career, so the things that I've like struggled about, that to learn in a structured way. Like I didn't know like uh, why to use SQL, or why to use MongoDB, right? Or in a messaging service, let's say, why to use Kafka, or why to use like any cloud public service like PubSub, or in Amazon, I don't use Amazon AWS. So why to use? I know how to use, but why to use this? So this is something that like hindered my learning. So obviously you will going to need, if you are like, if we want to be a data engineer, I will like recommend you guys that have follow the like a structured part, which is designed by the like in an industry standard manner. So let's say in this you have to learn Python for sure. For basic computing, you need to learn Python. You need to learn pandas, numpy, scikit-learn, not scikit-learn, forget about it. Pandas and numpy. You need to know how to play with CSVs file, right? You need to learn what is MongoDB SQL, and you need to learn how to deal with big data, like the large amount of data, right? So this is the great learning curve. After big data, after doing the data processing and batch processing, you need to learn how to configure SQL or how to configure any database system in any cloud. Then and how to use these 5 things, the 1, 2, 3, 4, 5 inside the cloud, right? And these are just the application, as someone said, like it's like an infrastructure, sorry, platform as a service. You will use it inside that cloud, but before using cloud, you need to have a prerequisite, like a journey, a learning, which like includes these guys. So just like think accordingly, like it will, like you can easily in a month or two, you can easily easily able to learn all these things in a good manner. So guys, if you guys have any questions, you can like ask, or if you think like you didn't understood some things properly, or so you can like easily connect with Digvijay like anytime after this call also, and we will make sure to answer you guys correctly.
Right. So again, thanks everyone for joining, and thank you, Saurabh, for I know that we have exceeded the time limit, so I really appreciate you making up for it. So yeah, I think we will be ending the session now. I think I will be here for just a minute or two. Thanks.
Sure.
Thank you again, guys, for joining.
Sure. Thanks, guys. Yeah. Have a great weekend. Bye bye.